Okay, students, today we're going to talk about experimental probability, and we're also going to talk about error and percent error. Okay, so there's some definitions that we need to talk about. So number of trials is how many times something happens. Outcome, which is like what is the outcome of what's going to happen. So like in this outcome, the cone is either going to land on its side or it's going to land on its base. Frequency of a particular outcome, so how often it happens in an experiment, and relative frequency of an outcome is the outcome expressed as a fraction or percentage. So in this example here, we've got a cone that's thrown on to a table 279 times. So it's either going to land on its side or it's going to land on its base. So after this experiment, they've found that it landed on its side 183 times and it landed on its base 96 times. So from this information, we can set up an experimental probability that says it's going to land on its side 183 over 279, and we can say that it's going to land on its base 96 over 279. And if you look at these two fractions, you can add them together and they will always add up to 100%. In IB, make sure you write your answers in 3 significant figures. Okay, we're going to do problem number 2 now. Okay, so they've given you some information. Jose takes a survey on a television, and he wants to find out the experimental probability that random TV commercial will last 20 to 39 seconds. So the first thing before we can get started is we need to figure out, we need to add the total of frequencies, which is 78 total. Now, 20 to 39 seconds, I look here, in 20 to 39 seconds, I'm going to have 38 in my numerator. Let's do the next one here. More than 1 minute. So more than 1 minute is going to be, it's going to be 4. Okay, because all of these are less than 1 minute. 59 seconds is less than one minute. And question C, what color marker have I not used? Let's use green. Between 20 and 59 seconds inclusive. So between 20 and 59 seconds, so that includes these two. So I add 38 plus 19. Okay, and then these are my answers to 3 significant figures. Okay, let's do the next question. Okay, question A says, how many days did the survey take? So from the records, the phone calls she received over a period of consecutive days. So from the table here, these are the number of phone calls per day, and these are the number of days. So when you look at this table, you can see that Bertul received 0 phone calls 2 days, and 1 phone call for 7 days, 2 phone calls 11 days. And so if I add all of these columns together, we end up that we've got 43 days. Okay, and so that's going to be my denominator for this experimental probability. Okay, so the first question is, what is the chance that there's no phone calls on one day? So if there's no phone calls on one day, I'm going to use this column here, and that height and value is 2. And that's how I get this one here. Okay, for question II, what's the probability that it gets 5 or more calls in one day? So these columns here are 5 or more per day. So I add this total, which is 4, and then 3, and then 1 from these 3 columns here. And there's nothing here for that column. Okay, last one. Let's use green. Okay, less than 3 calls per day. So, so this is less than, it doesn't say not including. So I'm going to use 2, 1, or 0, 1, and 2. And I'm not going to include this one here because it says less than. It doesn't say including 3. So adding those columns, I've got 2 and 7 and 11 in my numerator, because these are going to be, this is the experimental probability that I'm going to have less than 3 phone calls per day. You may want to hit pause and watch this some more if you need help. Okay. Find the probability that a person who visits in June was on a holiday. You may want to hit pause and read this if you need extra time. So for this question, the first thing I did was I calculated, okay, so visiting in June was a holiday. So I see, okay, June. So the number of people visiting in June, okay, and if it was a holiday, there was 156,000 people. Okay, and that's how I get this answer here. And then I round it to 3 sig figs. Okay, question B. Find the probability that a person coming to Australia arrived in May. So my denominator, I had to take the sum of all the 3 months, so April, May, and June, and that's my denominator. And my numerator is that they arrived in May. So this value there. Okay, and question C. Lars arrived in Australia April, May, or June, and he came to visit his brother. What is the probability that he arrived in April? So my denominator has to be the numbers of people arriving in April, given that they are visiting friends and relatives. So, so people visiting friends and relatives, I'm going to add these 3 values for my denominator, because these are the only people visiting friends and relatives. All the other ones are different. And then my numerator is the probability that they arrived in April. Okay, and this is called conditional probability, and we'll talk about that in our lesson down the road. Okay, next one here. Okay, we've got a table. Find the probability that a complaint was received in this year, 208-09, was customer service. So in 208-209, the total here was this value. Notice we got that there. And the complaint was customer service. So we go to customer service, and that's my numerator. Okay. Now, the next one. At any time during the 4-year period, what's the probability that it was related to billing? So at any time in the 4-year period, so I have to add all of these together, and that total is this value here. So that's my denominator. So this is any time during the 4-year period, I need that total. And the probability that was related to billing, I'm going to take all of these values here, and that's going to be all of the people that had troubles with billing. And so the probability that it was related to billing using experimental data is going to give me this. Okay, question C. The probability that it is not related to faults or billing in the year 2009, 2010. So my denominator is going to be from the year 2009, 2010, and my numerator is going to be everything except billing and faults. So I'm going to add all of these except billing and faults. So these ones here with billing and faults, I don't put them in the numerator. Okay, and let's go to the next one. Hit pause if you need to see this again. Okay, now we're going to talk about solving using grids. The grid really helps with certain types of probability questions. Okay, so you're going to spin a square spinner. So here's my square spinner, and you can get values of 1, 2, 3, and 4 on the edge, and we're going to turn it twice. So we're going to draw a two-dimensional grid and use the grid to determine the probability that both spinners get a 3. So if this spinner gets a 3 and this spinner gets a 3, we have a 1 out of 16 chance that we're going to both get 3s on both spinners. Question B, getting a 3 and a 1. So to get a 3 and a 1, I can go get a 1 and a 3 here, or a 1 and a 3 here. So these two is going to give me 2 out of 16. The next one, an even result with each spinner. So I could get a 4 and a 2, I can get a 4 and a 4, I can get a 2 and a 2, and a 2 and a 4. So from this information, we know that there's 4 out of 16 chances that we're going to get an even value. Hit pause if you need to see this some more. Okay, next. You're rolling a pair of dice. There's 36 different combinations from this. So what's the probability that you're going to get 2 number 3s? So if I'm going to get 3 twice, there's only 1 chance that that's going to happen out of 36 chance. What's the probability that you're going to get a 5 and a 6? So this blue one here is when I get a 6 and roll a 5, and this one is when I get a 5 and roll a 6. Okay, there's only 2 chances there. All right. Question C says, what's the probability that I'm going to get a 5 or a 6? So here I get a 5, 1, 2, 3, 4, 5. And here I get a 6, 1, 2, 3, 4, 5, 6. And then these down here, I get a 5. And here I get a 6. So we don't care what the other values are. And none of these ones that aren't highlighted can be counted because this is like a 4 and a 1. And this one here is like a 2 and a 3. So none of these have I rolled a 5 or a 6. So I count all the pink ones together, and that gets me 20 over 36. This question D says at least 1 6. So all of these values that I've highlighted in orange, you count them all together, you get 11, and that's the probability of getting at least 1 6. Question E, exactly 1 6. So all of these yellow ones are exactly 1 6. Notice I didn't highlight this one because that would be getting 2 6s. Okay, the yellow ones add up to 10. What's the probability of not getting a 6 at all? It's all the blue ones, add them together, you get 25. Okay, now this one's a little tricky because they've asked you to find the sum. So you've rolled 2 dice and you've added the sums together. Determine the probability that the sum of the dice is 7. So these are the values here that I've so if I add 1 plus 1, I'm going to get 2. If I add 1 plus 5, I'm going to get 6. Here, if I add 6 plus 6, I'm going to get 12. So all of these numbers that I've written here are values that I got when I added the numbers together. So 3 plus 3 is going to give me 6, for example. So to figure out when the sum of the dice is equal to 7, added those together, and I get 6 over 36. Okay, for this next question, same sort of thing. You're adding the value of the dice together. Okay, so what's the probability that you're going to get a score of 11? So if I add 6 plus 5, I'm going to get 11, and if I add the 5 and the 6, I'm going to get 11. So that's 2 out of 36 chances that I'm going to get 11. Let's look at the blue one. What's the probability that the sum is going to equal 8 or 9? So all of these that I've highlighted in blue, like this one, for example, is 6 plus 2 is going to give me 8. Here, this one here is 5 plus 3. It's just going to give me an 8. So the blue ones that I've highlighted here give me a sum of an 8 or sum of a 9. Add them together, divide by 36. The red ones, what's the probability that I'm going to get less than 6? All of the red ones I've added together, and I get less than 6. Okay, question 2. Now this one's a little different. This one says we're drawing the table, and the smaller number is subtracted from the larger number. So this is a little different. So this is subtraction. Okay, so these values, if I do 1 minus 1, I'm going to get 0. If I'm going to do 2 minus 1, I'm going to get 0. If I do 6 minus 1, I'm going to get 5. So these are the values I get when I subtract the larger number from the smaller. So like if I do 6 minus 1, I'm going to get 5. Okay, so now I'm using those numbers, I can answer this question. So what's the probability that the result is 0? And I add the yellow ones together. What's the probability that I get a result of 2? I add the blue ones together. What's the probability that I get greater than 3? I add the pink ones together. And all of those are divided by 36 because those are all the possible examples. Okay, I'm going to record this one in a separate video.